Okay, today we're going to be doing 5 medium level integrals. So our first integral is x squared plus 3x plus 5 multiplied by dx. So we'll notice that these are 3 things just added together, so we can split them up into 3 different integrals. It'll be x squared multiplied by dx plus the integral of 3x multiplied by dx plus the integral of 5 multiplied by dx. Now this is a lot easier to work with, and it's just the simple rule of adding 1 to the exponent and dividing it by the same thing. So we'll know that x will become x cubed divided by 3, plus we're going to add 1 here, so it'll be squared, and we'll divide it by 2. So it'll be 3 over 2 x squared plus, and then the 5 is just going to add a variable, which will be x. So we'll get 5x, and then we have to add our constant c at the end. Our second integral is the integral of sine of x plus cos of x multiplied by dx. So this follows the same principle as the last question, where we split it up into 2 different integrals because of the adding. It'll be sine x plus the integral, don't forget the multiply by dx, plus the integral of cos at x multiplied by dx. Now, this is a lot easier to work with. We know that the integral of sine x is going to be negative cos x, and we know that the integral of cos x is going to be sine x. And then we have to add our constant of c. To make it a little bit nicer, I'm just going to put the sine in the front. To make it sine of x minus cos of x plus c. So question 3 is a nice and easy integral. It's just the integral of e to the x. So what we can do here is we know we have to do e to the x ln of e, and then the ln and e will cancel each other out, giving us the integral of e to the x just being e to the x. And if you're confused why this is a thing, watch my other video where I go into it with more depth. So this question might look a little bit hard to start, but it's not that bad. What it is only difference between this and a normal integral is the square root. So what we can do instead is we can write it as x to the 1/2 multiplied by dx, because that's the same thing as writing the square root. Now what we can do for here is our normal integration, where we add 1 and we divide it by 1/2 plus 1. So now we're going to have x to the 3/2 divided by 3/2. But we know by fractions, the 2 will be brought up here, and our final answer will be 2 over 3 multiplied by x to the 3/2. So question 5 is the integral of x squared multiplied by e to the x. So what we're going to start with is doing the integration by parts. So we have to split this up into 2 parts, an f and a g prime. And we're going to make it so that that integral looks like this, and it's going to equal f multiplied by g minus the integral of f prime of g. So since we know that e to the x, the derivative and integral are both e to the x, we're going to call that our g. So it doesn't have to change. And we know that our x cubed is going to be our f, because that will make it a lot easier for us. So this integral will now look like x cubed, which was our f, now multiplied by our g, but since that's the same as the g prime, it's still going to be e to the x, minus now the integral of f prime. So that means we got to take the derivative of x cubed, which we know is going to be 3x squared. So it's going to be 3x squared multiplied by e to the x. So what we could do now is we could take this out and put it in front of our integral, because we notice that this gives us the same problem as before. We need to do another integration by parts. So we're going to have x cubed multiplied by e to the x minus 3, and big bracket, and we're going to make our e to the x our g again, and we're going to make this our f again. So we know that we need f multiplied by g, so it's going to be x squared multiplied by e to the x, and we're going to subtract our integral of f prime g. Well, we know that x squared, the derivative, is going to be 2x. So we're going to do the integral of 2x multiplied by e to the x. Now we can take the 2 of the integral again, and we realize we have the same problem one last time. So we need to make it x cubed multiplied by e to the x minus 3, big bracket, x squared multiplied by e to the x minus 2. And now we need to do integration by parts one more time. We're going to keep going with this being our g prime and this being our f. So we need our f multiplied by g, which is nice and easy because that'll just be our x multiplied by ex one more time. And we're going to subtract, but this time it's a little different with our integral, because we need the derivative of x, which we know is just 1. So it's going to be the derivative of 1 multiplied by e to the x, the integral, sorry. But we know that the integral of e to the x is itself, so we can take this all out. It's just going to be subtracted by e to the x. Now it gets a little tricky because you have to implement all of the 2 and the 3 to make it simplified. So we're going to start off by putting in the negative 2 into everything here. We're going to make it x cubed multiplied by e to the x minus 3. Keep this all the same, where it's x squared multiplied by e to the x. And we're going to put the negative 2 in. So it's going to be negative 2 x e to the x plus e to the x. Now we got to implement the negative 3 everywhere. We're going to make it x cubed multiplied by e to the x minus 3 x squared multiplied by e to the x plus 6x e to the x minus 6. There should be a 2 here, and this will be 6 e to the x. Now, as a final step, what we can do is we notice every term has an e to the x, so we're able to factor it out. We'll have x cubed minus 3x squared plus 6x minus 6, all multiplied by e to the x. And since it's an integral and we're not solving it, we need to remember to add our constant of c at the end.